Hello everyone, I am Monica. I am currently pursuing my BTech in Electrical and Electronics Engineering at Nadimpalli Satyanarayana Raju Institute of Technology, Andhra Pradesh. I have recently completed my IoT internship at Emertxe company where I have gained in hands-on experience in embedded systems and IoT applications. So, this presentation, I will be explaining my internship journey and what I have learned, and my final project about IoT based home automation system using Arduino, PICSimLab, and Blynk IoT Cloud. So, let's go into the presentation. In this internship, I gained a lot of experience of and gained in programming languages of C and C++, and then briefly explain about embedded systems and IoT and implemented the basic project, and then it all combined to the final project. In final project, we used Arduino IDE and PICSimLab Simulator and Blynk IoT mobile application. These are the topics we have learned during internship. First day of internship is introduction to C and controlling statements, operators, arrays and jumping statements, functions and pointers, in pointer types, memory segments, and storage classes and preprocessor directives, and introduction to C++, OOPS concept, and comparison between C and C++. Topics we have learned during internship in project part. First, what are the project requirements and what are the required components we used in these projects are Arduino board, sensors, and microcontroller like Arduino board, and we use connectivity of Ethernet shield and actuators, LED and heater, cooler relays and water tank control valves, and sensors like LED, LDR light sensor and LM35 temperature sensor, and CLCD we use it for display the values, and we use the cloud platform like Blynk IoT app for remote monitoring and co interface, and we use the development part like PICSimLab Simulator for safe prototyping and testing. And we also know about the PWM pulse width modulation concept using analog write, and where the application and where are the PWM we can use it like applications like motor speed control and LED brightness. And serial tank is this serial tank we use it for water level sensor integration, displaying level data over serial monitor, and Blynk app integration, overview of Blynk IoT platform and steps to install Blynk app and create project and create data streams, and controlling device view mobile, Internet of Things, IoT or the IoT. It is a network of physical objects, devices, vehicles, appliances that are embedded with sensors, softwares, and other technologies to connect and exchange data over the internet. And these are the applications of IoT. We can use smart home, wearables, industrial, embedded systems. An embedded system is combined with software, both software and hardware, to perform a dedicated function. These are the examples of embedded system, and core components we used microcontroller and sensors, actuators, and where we can use it and applications of embedded systems are these automobiles, medical monitoring systems, etc. And it is the Arduino IDE, and we used in this project Arduino IDE simulation. And the Arduino IDE is a free open source software we use it to write and upload code to Arduino boards. It includes a text editor, compiler, and serial monitor. And in this Arduino IDE, we used it in a simplified version of C and C++, and the software comes with numerous libraries. And this version is used in this final project. And PICSimLab. We used this PICSimLab simulator in our final project, and that simulates microcontroller hardware and its application connections. The simulator, we use it to implement the program while we write in the Arduino IDE, and in PICSimLab we can file in .hex files from an IDE, and the output is observed according to the parts used in PICSimLab. And these are the project requirements. We have three requirements. First one is garden light control. In garden light control, we used read the LDR sensor value. Based on the reading from LDR, vary the brightness of the LED, which resembles controlling garden lights based on the availability of sunlight. And the second project requirement is temperature control system. The temperature control systems consists of a heating resistors, an LM35 temperature sensor. We can use it to detect the temperature, and a cooler which resembles the temperature control system at home. The temperature from LM35, we can read that room temperature and it display on the CLCD, and we can control the system turning on and off the heater and cooler through Blynk IoT mobile app. And the third requirement is water tank inlet and outlet valve control. We can read the volume of the water in the tank through serial communication, and it also display on the CLCD, and it also display on the Blynk IoT app. And we can control the volume of the water of inlet and outlet valve by sending commands through serial communication, and we can also display all the values on the CLCD. And this is the basic block diagram of controlling the water tank inlet and outlet valve. And these are the steps to implement that project. First, we learned about introduction to IoT, and what is the embedded systems and how can we use it like that. And we can install Arduino IDE and PICSimLab simulator, and we can working of LED and LDR, and we can control the basic programs of LED using LDR, and about CLCD interfacing and how it's working. And we can also write the code using temperature control, and basic program related serial remote tank, how it can display on the CLCD like that. And we can also introduce the Blynk IoT application, how can we use in this project, and installation of Blynk IoT, and we can also write the programs of Blynk IoT applications, and we can implement that final project. In using these basic programs, we can implement the final project. And this is the Blynk IoT mobile app. We can see in that mobile app so IoT device connects via Wi-Fi, that we can control a component connect through the Arduino through Wi-Fi from anywhere in the world. So we just need Blynk. According that we have pasted in the code in Arduino IDE. So using the Blynk account, we can control the device from anywhere. So we also learn how to integrate Blynk to our project. And this is the IoT based home automation using Arduino IDE and PICSimLab Simulation and Blynk Cloud server. By connecting mobile app, we can use it how to control garden lights, temperature systems, and water volume. Now let's move to the project demonstration part. This is the Arduino IDE user interface, and I created the subprograms of for each component like LER and serial tank and temperature system. Finally, we can combine all these programs of home automation. We can use the main files like Blynk template ID and template name, device name, authentication, and can use some libraries like Ethernet and Blynk Simple Ethernet and temperature system and serial tank. These are the libraries we use it for based on the project requirements. And this is the LCD from display on the CLCD. And we have two pins like cooler pin and heater pin here, and we can control this cooler pin and heater pin, and it display on the LCD by using LCD.set cursor. And both it can display on the Blynk app for control through Blynk IoT app. And we have also a outlet and inlet valve from outlet and inlet valve like that, and we can also control the Blynk IoT app, and it display on the LCD. And next, update the temperature. Uh, Reading the temperature values and update it real-time temperature on gas, and when the temperature exceeds 35 degrees centigrade or greater than 35 degrees, then the heater pin automatically turn off, and it can display on the LCD the heater is turned off like that. And we have to control the handle tank. If the water volume drops below 2000, then the inlet valve on automatically, and it can display on the LCD. And where the volume is equals to 3000 or the tank is full, the inlet valve is automatically off, and it displays on the LCD. This step function this function is called as smart water management. In this step function runs once to initialize modules, and the loop function repeatedly calls the subsystem for continuous operations. And the next the subprograms of the files is LER for garden light control, and serial tank for what inlet and control the inlet and outlet valve of water tank, and heater and control the heater and cooler pins of temperature system. And this is my final project code, and we can compile it. While we can compile it, and we then I compiled it successfully without getting any errors. Then I can export compiled binary. Once it compiled, then we can go open to the PICSimLab. Here we can upload that code using .hex file from automation. Then I upload. Here I can upload my file .hex file using, and I can select the board of Arduino Uno. And let's start. Here we connected LCD, LDR and LED, and here we using Ethernet by network connectivity. And here is temperature, and we can see the temperature values at room temperature. And here you can get your serial tank values, and here the serial tank is full, then it shows 3000. And by using LDR we can control that LED brightness, and if the LDR is low then LED is off, LED is on automatically. Then I using, and then here we can see that Arduino template device name. And if the heater switch is on, then it can see shows that heater is on, and we can increase the values, and it can be shows it in Blynk IoT app also. And if the cooler switch is on, then we can see that cooler is rotate, and this we can see the display LCD display on heater is off, and we can decrease the heater values. And like that we can on that inlet valve, we can on that outlet valve, then the water is dropping, and we can decrease the values in the Blynk IoT app, and we can also see that LCD also. So if the Blynk IoT, so we can see the Blynk IoT app, how can we control that temperature system and inlet valve, water control system. And we on that inlet valve, and if we can see that the tank is full, then the inlet valve is off automatically. See that if the tank is full 3000, then the inlet valve is off automatically. Then we can on that outlet valve, then it shows it outlet flow on. And if that volume of the tank is 2000, then the outlet valve is off automatically, and we can on inlet valve. See if that inlet valve is on automatically. So if that heater is on, if the heater values is 35 degrees, greater than 35 degrees, then the heater switch is on, off automatically. We can see that is 2.23. And if we see that 34.67 like that, if that she is 35.16, then the heater switch is off automatically, and we can control like that using Blynk IoT app of heater and cooler. If the tank is full, the inlet valve is off automatically. If the tank is below less than 2000 or below 2000, then the cooler outlet valve is off, and that heater inlet valve is on. We can see that inlet valve is on automatically. So this is my final project while controlling that Blynk IoT app using Arduino components, and we can display it all on CLCD. Now so this is overall my project demonstration part, and by getting conclusion, so we can see that my overall project demonstration part. So by using mobile app we can control, so by using Blynk IoT app we can control garden lights, inlet and outlet valves of water systems and temperature system by using PICSimLab Simulation. So let's move to the overall feedback and conclusion part. Overall, this internship helped me a lot of strengthen my programming fundamentals in C and C++, and again real world experience with Arduino and IoT devices, and also build for innovation, logic development, And working on the final home automation project, improving my debugging, design thinking, and integrating skills. It also taught me the importance of documentations and innovation. Overall, this internship has been a major stepping stone toward becoming a skilled IoT and updates system developer. Thank you for watching my presentation, and also thank you for Ametex Technology.